Hello folks, welcome to another mini machining video. It has been a little while since I've done a video, a few months. I do apologize for that. To get to our topic today, we're going to talk about CNC, and we're just going to start with an introduction for those of you not familiar and start covering very briefly some of the options for setting up a CNC machine. To begin with, CNC stands for Computer Numerical Control. This, or computerized numerical control. It's basically using a computer which will send a series of signals that are numeric in nature to a machine such as a mill or lathe in our case to move the axes automatically rather than you hand cranking them as we have been doing in all of our previous videos. The advantages here is that the CNC can do far more complex moves in that it can move all three axes in the case of a mill, or four axes or more, at the exact same time and in a coordinated manner. Now, you're probably only going to be moving, when you're doing machining manually, you're only going to move one axis at a time. Then you'll switch, move another axis, go back, move another axis. So CNC gives us that ability. CNC also gives us very accurate and repeatable results. So as a human turning a wheel, with practice we can get better at that, but we are still going to always have some inconsistencies. We are also going to be limited on how quickly we can turn that wheel. And from time to time, one time we might turn it slightly faster in the number of revolutions per minute or revolutions per second versus the previous time, so we don't necessarily get repeatable results. With a computer, it can turn exact same speed 24 hours a day if the machine can handle doing that. These hobbyist style machines, I wouldn't recommend trying to run 24 hours a day. You'll burn them up pretty quickly, but just as an example there. To begin, we have a couple of options for CNC when we're talking about Sherline and hobbyist style. We have 3 software packages out there from 2 manufacturers. The first runs on a Linux operating system, if you're familiar with Linux, whether that be Debian or Red Hat or some other distribution. It was previously known as EMC2, and you'll still see that listed a lot, but I imagine because EMC, and specifically EMC2, is a trademarked name of a much larger computer company, that they changed the product name to Linux CNC. I don't know if that was due to copyright infringements or if that was just another reason. So Linux CNC is the software that you will run on Linux if you want to run a Linux operating system. That software is entirely free. It's not necessarily as user-friendly. It may not be as feature-rich as some of the commercial products out there, but it is free, and it does have a very large support from a very large community base. So if you're okay with Linux, and if you're okay with tinkering and really getting into some of the details and the nitty-gritty and doing a lot of customizations yourself, that may be the path you want to go. The other direction on the Windows side, from a hobbyist standpoint, is either Mach 3 or Mach 4. And those 2 packages are probably the most popular on Windows. There are certainly other options out there, but we're going to stick with the popular ones. Mach 3 is a little bit older, but Mach 3 does allow us to use parallel ports, which we'll look at here in a little bit, and will run on some older operating systems, whereas Mach 4 only works with motion controllers. Again, we'll get into those details a little bit later. From my playing with them both, I definitely like the Mach 3, Mach 4 interface a little bit better, and I think it's easier. However, there is a cost associated with that, right? The license is between $150 to $200 depending on what you buy, and obviously you have to have a Windows license on top of that as well. Now you're going to need a computer to run those on. They do not recommend neither Linux CNC nor the manufacturers of Mach or most CNC software packages out there do not recommend you run it on a laptop. However, that said, many people do run it on a laptop successfully. You may just have some problems with missed steps and things like that. We'll get into some of those hardware specifics once we start looking at the different software though. But you are typically going to want a desktop style computer. You know, particularly in the case of Linux CNC, this can be a much older, lower end computer, and it will run it just fine. You don't need the latest, greatest, hottest, fastest computer out there. After you've got your computer and your software selected though, the next thing that you really have to decide upon is how you're going to interface your computer into the rest of your CNC hardware. Traditionally, this was done with what's known as a parallel port. This is a DB25 connector. It has 25 pins on it. And you'd use anywhere from 1 to 3 of these parallel ports in most common setups. You could certainly go more. For very simple setups, you'd only use 1. As you start getting more limit switches and more drives and more variables that you want to control, then you'd need more ports or more pins, and hence more ports. The problem is that the parallel port is kind of going the way of the dinosaur. This used to be the primary method that printers were connected. And if you think about it, a printer is a very, very basic CNC type of machine. It simply has one axis that moves left to right. It has another axis that will advance the paper. And then it has some other motor control for the head, whether it be a dot matrix or daisy wheel or more modern inkjet. And the quality of these parallel ports has also changed. So these parallel ports may not always output the best signal quality that we would need for CNC and reliable CNC. So there are some ways around that though. Linux CNC definitely supports this, and then Mach 3 on Windows XP or Windows 7 will support a parallel port. Once you get into some of the newer versions, you're going to have a harder time supporting a parallel port. Now, you might do a quick web search and find that there are a lot of USB to parallel adapters. I'd be very wary about those, and a lot of people have a lot of failures with those because the chipsets in those are very, very low quality. And you are going to run into a lot of problems because we're dealing with real time. We need the signals from each one of these axes to be very, very exact and very precise, and at the time that we send the signal. Some of those USB to parallel adapters will add in some delay and add in some other variances that will cause problems in the CNC world. So be very, very wary of those. You want to either get a built-in one or try to find a good quality aftermarket add-on card like this for a desktop computer. Now, I just mentioned being careful about USB, but here we have a USB card, and some of the newer hardware and modern hardware is starting to move towards where we're using USB as the interface. A lot of times this interface will end up being to another device that helps boost the signal and convert it into a parallel signal, or it will be to what's referred to as a motion controller. And we'll look at motion controllers in a minute. Motion controllers are really where things are going with CNC. And if you can't afford to get a motion controller set up, I highly recommend it because you'll be able to use the newest software and a lot of the newer features and newer hardware. And the setup is really a lot simpler as well because you take a lot of the load off of the computer and a lot of the intelligence off the computer. But we'll get into motion controllers in a minute. Motion controllers are very frequently connected via USB, or the other option for motion controllers is via Ethernet. And this is actual Ethernet, not just simply an RJ45 connection. They do recommend using a dedicated Ethernet cable from your computer. So your computer will probably have at least one Ethernet connector on it. Most desktops do today, even laptops. And you'll want to take the Ethernet connection from your computer into the motion controller directly. You can, in theory, run it over a network through a hub or a switch, but you risk inducing problems then. So the recommendation is to run it directly. So the way I run my motion controller is my computer has an onboard Ethernet that I run directly to the motion controller, and then I've bought one of these little USB to Ethernet adapters. This allows me to get out to the internet for any software updates I want to do, or if I want to copy a file to the computer, things along those lines. Use a separate physical Ethernet like this, or do a wireless Ethernet adapter. Next item we're going to look at, and we're going to go into all of these in a lot more detail in other videos, but quickly just kind of giving you an overview of some of the pieces and parts you can use. This is the Sherline CNC controller, and it has integrated motor driver in it as well. This is the most basic setup that you'd have. If you were to use a pure Sherline system, this is what comes from Sherline in some of their CNC kits, or when you purchase it. It does have a parallel port on it, so you have to have a computer with a parallel port. So this would go to your computer. And then it has a power input, and this is a fairly hefty power input on this unit because it does have the motor driver integrated into this, so this sends the power to your motors as well. This has just a simple on-off switch. And on the back side of it, we have our 4-axis X, Y, Z, and A. So this can be used on a lathe where you would normally just use the X and the Z axis, for example. Or if you're going to use this on a mill, you'd use minimum the X, Y, and Z axis typically. The A axis is if you have a rotary table. These cables are fixed, and they run to a DIN connector on the other end. So the next component we're going to look at is the stepper motor. Now, motors come in a couple of different varieties. We have stepper motors, which are the basic and lowest cost options. These will come in different sizes, and they're listed as a NEMA 23, for example, is this size. As you go up in numbers, so the motors get larger and more powerful. And the power output of these are listed usually in, say, ounce inches of torque or some other measurement of torque. These happen to be dual output, so we've got an adapter here, and then in this case we'll drive a rotary table, but this would drive the XYZ axis just the same. And then on the other side, which is the dual output, is a connection for a hand wheel. So we can turn this manually if we wish, versus a single output. If you're only ever going to do CNC and you never need to have a hand wheel, then you can get a single output shaft for your stepper motor. Above this is what would be considered a servo motor. The servo motors are nice because they give you a closed loop versus this is open loop. Open loop means the computer sends a signal to this motor saying move this far, this fast, and the computer hopes the motor receives that signal and performs the action. There is no feedback from the motor to the computer saying, yes, I did indeed move that number of steps, and yes, I performed the operation as you requested. A servo motor, on the other hand, is a little bit more intelligent in that it can more accurately measure its movement and provide feedback on that movement. You'll hear about missed steps on stepper motors like this. Missed steps you really don't run into on servo motors. This is the Sherline motor and adapter that comes in their CNC kits if you go their route. If you go a build your own route, you can put whatever you want on here. So this one has a flat connector. It actually has 6 pins on it. And then this flat connector, they include the adapter to a DIN, so you can plug these two together. Some motors will simply have a terminal block on here. Others will just have the wires coming straight out of them with no removable adapter. Just different options there. So one note of caution, when you run these stepper motors or servo motors by hand like this, what you're essentially doing is you're turning this into a generator. So instead of sending power into the motor to move it electronically, moving it manually, you're sending power back down this cable. And that can damage your electronics. Each motor will have a different safe limit. Your best bet, though, is if you are going to manually be turning them a lot, simply disconnect them and definitely power off your controller. Usually with your controller powered on, you're not going to be able to move this anyways because the motor locks it into place. On these particular motors, you can get by with 1 revolution per second without causing damage in theory, but I would still go the safe route and disconnect it. So that's the most basic setup that we can have, is your computer, whatever software it's running, a parallel port on it, running to an integrated controller and motor driver, such as this, and then that motor driver outputting the power to your motors. That's the most basic setup. From there, we can put other devices in the middle to give us other functionality. So one of the devices we can put in the middle is this unit here. This happens to be made by, I believe it's DPP Engineering, and I'll put up their website address. This you can get if you purchase the Ultimate Machine Shop CNC kit from them, which is where I purchased it from. You can get this as an add-on option. Before I mention the poor quality parallel communications and parallel ports that are found today, this helps alleviate a lot of that. So we get our connection in from our PC, and this will regenerate and kind of boost and clean up the signal before sending it out to the controller. So we'd still use that same controller that we showed previously in this case. This also gives some additional breakout board functionality on it. We have a probe that will allow you to basically measure objects in 3 dimensions. So if you've got something you want to replicate that's got some curves and steps and things along those lines on it, you can hook up a probe, and this will allow you to, that probe will go and touch points on the object and kind of trace it in 3 dimensions. We have a USB power input on this, which is nice, so it's powered off of the computer rather than needing another power brick and another outlet. This has set up for limit switches right off the bat, so you can plug in a series of limit switches off of here, which stop your machine from moving too far in one axis or another in case something gets a little bit out of bounds. And then an expansion port for additional features and functionality. So this is another little box you can buy. This simply enhances the Sherline, and it's made specifically for use on that Sherline controller. I wouldn't necessarily use this with some other controllers if you are going to go the route of a different controller. This still does use parallel, so we are still on that very basic and older style legacy parallel connectivity. Now the next box I'm going to show you here, this is actually a motion controller, and this can be used in conjunction with one or both of those other boxes. You probably would eliminate the DP Engineering box if you wanted to. You wouldn't necessarily have to have it. Inside this box is what's known as an Ethernet smooth stepper, and smooth stepper is one of the more popular motion controllers out there. They make both Ethernet smooth stepper as well as a USB smooth stepper. And this is then a kit, because the smooth stepper is just this board on the inside. That's the hardware. Now you can either assemble all these other pieces yourself, the box, the ribbon cables, the different connectors and ports, or you can buy a kit, as I've done here, that simplifies some of the setup for you. So in this case, we run Ethernet into this box, and this box is in its own right a small computer. This basically gets signals from your computer, and then this does all the parallel communications. It generates entirely on its own. It doesn't rely on any parallel communications from your computer. It doesn't regenerate or clean up or do anything along those lines. It generates them from scratch. It has parallel controllers built in specifically for CNC that are high quality, good quality, that allow you to do that. Now the Ethernet smooth stepper we'll cover in another video in detail. There are a lot of options. This is the most basic setup that you can do with them. Here again, you run Ethernet from your computer, and then we have parallel ports. We can run those ports to a controller, such as a Sherline, or a third-party controller, such as a Gecko G540 is a very popular one that also has motor drives built into it. And we have several other ports here. We've got a total of 3 parallel ports for doing other breakouts. There are a lot of different options, and we'll be covering them, some of them at least, in detail as we go forward. So then there are many other options that you can get to enhance and extend the functionality. I have a couple shown here, but there are dozens, if not hundreds, of different options. So here we have a speed sensor that we can hook up to a computer. It's got USB, so we can measure the speed of our spindle in our lathe or our mill. This is what's referred to as a pendant, and this is one of the fancier pendants. Both of these are made by a company called iMach, and a lot of these guys use the terms Mach or Warp 9 makes the CNC the Ethernet smooth stepper. So lots of speed names here. These controllers will often have, in this case, we've got an emergency stop switch. So if something goes wrong, this is a software-based one. You can also have hardware-based ones, which most people would recommend over this, but here you've got something right in your hand versus moving to hit. And this will allow us to control the steps. We'll go over this sort of thing in a lot more detail as well. This is a very nice one. This is one of the higher-end models, at least for a hobbyist or small business. Certainly there are fancier ones once you get into industrial applications. But rather than, with a device like this, rather than trying to manually turn the hand wheels on the machine, we can pick an axis and then turn this wheel. And this wheel may have, we've got steps, so we can feel those steps. It's very easy to move. There's no resistance on this. And there are a variety of other ways we can move it, where anytime we spin this, we can have it move at a constant speed versus whether we do it slow or we do it fast. But we'll get into a lot more on pendants. Again, this is a fairly fancy one, but it is a very nice thing to have if you're going to do CNC and you still want some manual control of your machine without having to disconnect power and things along those lines. And then we have limit switches. These are physical limit switches. There are inductive ones, there are magnetic ones, there's optical, there's so many different varieties of limit switches. The mechanical is definitely the simplest, and we'll get into both mounting these as part of the Frankenmill project, is how we're going to mount some limit switches on there and what their uses are. Limit, home, stop switches, different ways of detecting where the machine is at any given time. So I hope you find this introduction useful. We are going to be covering in a lot more detail all of these items, including installing the different software and the different software options. I'm not sure if I will cover both Mach 3 and 4, or if I'll just do one or the other. And then I am going to try to do both Linux CNC as well as one of the Mach software packages. I'll probably do Linux CNC on my lathe and Mach on my mill. I'm also going to try to bring you some other motor controllers and some other CNC controllers as we go. Those items do get fairly expensive though. We may also long-term start talking about variable frequency drives and doing a lot more high-end, but initially we're going to start at the beginning with basic setups and move from there. As always, if you've liked this video, please give it a thumbs up and be sure to subscribe if you want to see future videos. Additionally, if any of you have a preference of Linux CNC or Mach software, please leave that in the comments, and I can start to focus on one topic versus the other more, depending on what my viewers want, rather than just arbitrarily picking one.